Everybody, so these things, neodymium magnets, it could be argued they are at the core of our future because of course they're used in motors and generators, and as everybody wants an electric car and a wind turbine, then these are probably essential to future progress. Now the reason is they're strong. And if you think about your Lorentz law, then the electromotive force is strength of magnetic field, length of wire, velocity it travels at, and the angle that the wire cuts the magnetic field. So it's really important in generation and motors that you have a strong magnet. When these magnets came out, of course, they made a huge difference, and we referred to them as neodymium. However, they're only about 30% neodymium. The rest is iron and a little bit of boron. But even so, neodymium we all know as a rare earth material. Now, rare earth materials are a bit of a misnomer because they're not particularly rare. There's actually quite a lot of neodymium about. In fact, there's probably more neodymium than there is copper or zinc or lead. The problem with it is it's difficult to get out of the ground. Copper is really easy. I mean, copper was discovered, what, 5,500 to 5,000 BC? And that makes sense because in order to get copper from copper ore, all you really do is burn it with a bit of carbon at 1,000 degrees centigrade and out will come your copper. Chances are somebody just lit a campfire on a green rock and next morning found copper. But it was discovered early, it's easy to get out, and it was widely used. With neodymium, it's actually a nightmare. There's a lot of it, but it's spread out, it's difficult to mine, and it's difficult to process, and it can be described as less than environmentally friendly. Of course, the bulk of neodymium, something like 81%, is owned by China, and of course that leads people to an awful lot of worries about this sort of stuff. So, the idea of them being rare earth, and that rare earth means rare, is a bit of a misnomer. The idea of them actually being magnetic is also a misnomer. They're not magnetic, they're actually paramagnetic. Paramagnetic means it becomes magnetic under an applied magnetic field. Iron is paramagnetic. You know this, if you get a magnet and touch a pin, the pin will become magnetic. Now the thing about iron is it can become a permanent magnet above 770 degrees C, then is described as ferromagnetic, and that means that it can make permanent magnets. And there's a whole group of materials, things like nickel, iron, that sort of stuff, which will do that, but neodymium won't. So it really begs the question, what is neodymium doing in this in order to make this a stronger magnet? Well, like I say, it's paramagnetic. So it will form a magnetic field as long as there is a magnetic field already there. But magnetism, as well as a property of materials, is actually a physical property. It's a property of shape. If you can get a magnetic material into the right shape, then it's going to be a really big and great magnet. And of course this is something that's really well known and something that's been researched for a long time with lots of alternatives around that people are looking into because of the issues surrounding neodymium and our need for good magnets in the future. Now I'm sure lots of people know all about what I said before, but here is the absolutely fascinating bit, and really could only have been thought up by a science fiction writer. You know, if only there was a magical mineral like vibranium or something like that. And there is! It's called tetrataionite. Taionite is just a mineral of nickel and iron. It's absolutely everywhere, you're tripping over it. And tetra refers to the structure of it, and this particular material has been known about for ages and has amazing properties in terms of its magnetism. There's only one tiny drawback, and that is it's only found on meteorites. It needs to cool down a few degrees over millennia to allow that tetra structure to form, and that physical property is what gives the iron and nickel its magnetic property. And that's the only place that it's actually been found, in meteoric iron meteors. Ever since people have been stumbling over meteors and hitting them with hammers, they've known about it. But it's been impossible to actually make, and that was the case until 2022. The 25th of October 2022, this paper came out from Cambridge University, working in association with Austria, where by adding a small amount of phosphorus to a nickel-iron alloy that we're casting, it formed tetrataionite in seconds and in bulk amounts. You might believe that this has caused something of a stir. It's a very exciting development because it's taking super powerful magnets out of the hands of, well, what is basically environmentally damaging and politically controlled as a mineral, into a mineral that is just absolutely everywhere. Here in Kent, if you take a walk, you'll trip over iron. It's everywhere, and so it's a very freeing for everybody to have something that uses earth-abundant materials to provide something that is absolutely essential, or at least looks essential, for our future development. And what's really curious about it is it was inspired, if you like, from space, from meteors hitting the Earth and people investigating those. I found that absolutely brilliant. One might say that our future civilization is being saved from magnets from space. Anyway, I hope you found it interesting. Thank you very much for watching, and please do remember to like and subscribe.